Today we learned about stoichiometry, which is a way to figure out how much of one thing you need in relation to how much of another. We started off with understanding that moles, liters, and particles follow this 1 to 3 to 2 ratio in the notes. So you could really set up a proportion and say 1 is to 0.5 as 3 is to x. And then by cross multiplying, you could solve for x to be 1.5. An easier way to do this would be what we call the bridge. The bridge, you just have to remember to divide and multiply. So you divide by the coefficient and multiply by the new one. So you would do 0.5 divided by 1 times 3, and you would get 1.5. You can also do that to get this last answer by doing 0.5 divided by 1 times 2 equals 1. You could do that same proportion and bridge calculation for A, B, and C in the notes, but when you get to D, this deals with grams. Grams not only uses the coefficients, but also uses the molar mass of each substance. Please remember that you're adding up only the mass of this. You are not adding the mass with the coefficient. You're just adding it from the formula of the substance. So to do the big proportion, you could do in letter D, if you know the 6, you would do 3 times 2 is to 6 as 1 times 28 is to x. Cross multiply and find that it's x. Or the big bridge now, you divide twice and multiply twice. So you would do 6 divided by 3 divided by 2 times 28 times 1 gives you 28. If you want to go to part D, the products, you would do 6 divided by 3 divided by 2 times 17 times 2, and that gives you 34. You could follow the big bridge to solve each of parts E and F as well, and these are the answers that you would get. Now we move on to the next topic, which is called limiting reagents. So in chemistry, very often a reaction is going to stop because one of the reactants has run out. So let's take this example and see what happens. If we balance this equation, we'd put a 2 here, a 1 here, and a 2 here. And now we have to figure out which of these two is going to run out first. So what we could do is basically guess and see if we're right. So let's cover up this oxygen, and we're not going to know that we have 4 of that. So we don't know we have 4. So we're going to bridge from the 4 of the hydrogen. We're going to say 4 divided by 2 times 1 is 2. So 4 moles of hydrogen would require 2 moles of oxygen. So now you move your finger and see, do I have 2? Yes, I have more than enough. So I'm going to use up all 4 of the hydrogen. I'm only going to use up 2 of the oxygen, and I'm going to make 4 of the water. Now when you're all done, you'll be out of hydrogen. You'll have 2 leftover moles of oxygen, and you would have made 4 moles of water, and the limiting reagent is the one that ran out, which is the hydrogen. Now let's suppose we had originally guessed that the oxygen ran out instead of the hydrogen. So we would have covered up the hydrogen, and we would have said we don't know how much of that we have. Then we would have done 4 divided by 1 times 2, which is 8. But if we move our finger, we'll see that we don't have 8 of the hydrogen. We only have 4. So since we only have 4, we don't have enough. So we cannot run out of the oxygen. We would have to run out of the hydrogen. Okay, moving on to the next equation. We'll balance this equation with a 1, 3, 2. And again, we're going to try to figure out which one runs out first. Let's suppose we thought the nitrogen runs out. So we're going to cover up the hydrogen, and we're going to say we don't know that. And we're going to bridge from the nitrogen, and we're going to say 3 divided by 1 times 3 is 9. We move our finger and say, wow, we don't even have 9 of this. Therefore, we did not pick the correct one to run out, so now we're going to have to run out of the hydrogen. So we're going to cover up the nitrogen, and we're going to bridge from the hydrogen. We're going to say 6 divided by 3 times 1, which is 2, and this is going to work because the other way did not work. So this runs out of only 2. This fully runs out. And this is going to make, we're going to do the bridge again. So let's bridge from the 6. 6 divided by 3 times 2 is 4. And so when we're all done, we have 1 leftover nitrogen, no more hydrogen, and 4 moles of ammonia. So the limiting reagent is the one that ran out, which again happens to be hydrogen. And the one that's left over is called the excess reagent. So the excess in the first one was oxygen, and the excess in the second one was nitrogen, and the vocabulary for this would just be the product that you formed. If you move on to the next equation, you're going to need to do some balancing on this, and when you're all done with the balancing, you're going to find out that this is going to be a 4 for that ammonia, which makes a 2 for the nitrogen. 12 H's is going to be a 6 for the water, and then a 3 for the oxygen. Now what we're going to do is we're going to, again, figure out which one runs out. We're going to guess. Let's guess the ammonia. We're going to cover up the oxygen. So now we're going to say 16 divided by 4 times 3, and that is 12. We move our finger and we say, wow, we have exactly 12. So in this case, they both will run out at exactly the same time. Oops. So this is going to be a 12. And now we're going to use the bridge to figure out the nitrogen. So we could do 12 divided by 3, which is 4, times 2 is 8. So we're going to have 8 of this, and then we're going to make this one. We could bridge from the 12 again. 12 divided by 3 is 4, times 6 is 24. When you're all done, these both ran out. This was an 8, and this was a 4, and the limiting reagent was both. So note in these 3 examples that we used the little bridge because this was moles or liters, also particles would follow the little bridge. But in the last example, you're going to see that it's in grams. And when it's in grams, you have to use the big bridge. So what you have to do is you have to balance this. So this is going to be a 2 and a 1 and a 2. You're going to find the molar mass of each of the elements or compounds. Remember that you only use the formula, you don't use the coefficient to find the molar mass. So this is a 2, 32, and an 18. So now we're going to use the big bridge. All right, let's suppose we think the hydrogen runs out, think the 12 runs out, we're going to cover up the 16. We're going to do, just try to get this screen a little better here. Okay, so now we're going to have the 12 running out. We'll cover up the 16. So it's going to be 12 divided by 2 is 6, divided by 2 is 3. 3 times 32 is 96, times 1 is 96. We move our finger. We do not have even close to 96. So we cannot run out of the 12. We're going to run out of the 16. So we're going to cover up the 12, and we're going to say 16 divided by 1 divided by 32 is a half. Half times 2 is 1. 1 times 2 is 2. And of course, we have enough. Is going to be minus 2, minus 16, and then we're going to bridge to the product. So we could do the 16 again. 16 divided by 1 is 16, divided by 32 is a half, times 18 is 9, times 2 is 18. And you should notice something interesting about the grams in the change line is that they add up on both sides because 2 and 16 grams will form 18 grams. Limiting reagent was oxygen. And what you need to understand is that the change line is where you're going to use the bridge. If you like proportions, that's fine, or if you even like conversions, that's fine too. But this is the line that uses the bridge, okay, the change line. That's going to follow the proportions that we got from the equation. Little bridge for moles, liters, particles, big bridge for grams. Okay, now we're going to talk about percent yield. Percent yield. We're going to balance this equation. And it's a 1, 2, 1. So it says, suppose that 18 grams of carbon makes 20 grams of methane in an experiment with unlimited hydrogen. Find the percent yield. Again, this is going to be a stoichiometry problem. So if you have 18 grams of carbon, you're going to realize this is big bridge. So you're going to make this a 12 for the molar mass. You're going to make this a 16. I'm not going to worry about the hydrogen because I have way more than I need. So we're going to use big bridge. We're going to do 18 divided by 1 is 18 times, divided by 12 is 1.5 times 16 is 24. Times 1 is 24. So I'm supposed to make 24 grams. The bridge tells you what you're supposed to make. That's called the theoretical. Theoretically, this is what you should have made, 24. Theoretical. However, in real life, you don't always get what you're supposed to get. So we only made 20 in the experiment. Okay, that's called the actual, or you could call it the experimental. Either way. So to get the percent yield, you take the 20, what you got, divided by what you should have gotten, and then, of course, times 100. And that's going to tell you your percent yield. So on a calculator, you can do 20 divided by 24, and you're going to get 83.3% yield. So that's going to be actual over theoretical times 100. Okay, here's another problem, similar type of equation. Also going to be 1, 2, 1. Suppose that 49.7 grams of this makes 42.1 of that. Find the percent yield. So what you could do at home is you could try this, pause the video and try it yourself, and then check it after I'm done, after you're done. And then I'll do it up here. So this is 71. This is 154. When you add it all up, we're going to use big bridge. So 49.7 divided by 2 divided by 71 times 154 times 1 is 53.9. So you were supposed to make 53.9. Again, that's the theoretical. However, the actual, or experimental, is the 42.1. So you're going to take your 42.1 grams. 42.1 grams divided by the theoretical, which is 53.9 grams, and then times 100, and that will give you 42.1 divided by 53.9 equals 78.1% yield. Now let's suppose that the problem is designed a little differently where they tell you the percent yield. So they're telling you the percent yield in this problem is 70%. So this is the percent yield, 70. What you want to do is figure out how much would you get. So how much would you get is the actual. So we're looking for the actual. So what I can always do is figure out the theoretical with the bridge or stoichiometry, because I'm always going to have an amount that I start, with which I start. So let's go back to the equation. It's right here. We're going to use the big bridge from the 60. Now I am going to need the molar mass of this, which is 12. So I'm going to do 60 divided by 1 divided by 12 times 154 times 1. And that is 770. So I'm supposed to make, with 3 sig figs, 770 grams. I'm supposed to make that. I set up the problem exactly the same way, but now I already know the percent yield is 70%. So it's already a 70% yield, I know. And that's going to equal the actual over the theoretical. I know the theoretical is 770 grams, and now I just want to find out what will I make from that. So it's just solving algebra problem. So 0.70 times 770 will be 539. So this is what you would expect to get in the experiment if you're only 70% efficient. So remember, a problem can be designed in any way. It's not always going to ask for the same thing each time. But this is how you solve percent yield. Okay, next we're going to go to percent composition. If I say percent, you need to think of the word grams. So percent, grams, percent, grams. If I ask you for a percent, you have to find the grams of each part of the formula. So if I have CH4, which is methane, how much carbon is that? 12. How much does the whole thing weigh? It weighs 16, because this is 12 for the carbon plus 4 times 1 for the hydrogen. So that's 16 grams total. A percent is always a part over a whole. So part of the whole, 12 over 16 for carbon is 75%, and 4 over 16 is 25%. And so that's the percent composition of methane. So percent is by grams. However, if I say formula, you need to think moles. So formula, moles. When I'm trying to find the formula of something, I must find the moles. However, if I'm given the percents, that's like being given the grams. So percents are grams, formulas are moles. I'm given the percents, so I'm given the grams. You basically assume you have 100 grams of it, so 75% would be 75 grams, 25% would be 25 grams. But remember, you have to take a ratio of moles for a formula. So you need to convert the grams into moles with the periodic table, and then take a simple ratio for the smallest one. So 6.25 is the smallest, so that's going to give you a 1:4 ratio, which tells you that this is methane. We'll pause now and continue on the next video.